Sokotoa, 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 Sokotoa. All right, well, we're going to learn about an Indian, Native American tribal. No, I'm just kidding. Nothing with Native Americans, actually. But if you know that Sokotoa chant, then, man, you're going to be good to go for this lesson on trigonometry. This trigonometry and geometry actually go really hand in hand with sine, cosine, and tangent. So that's why our goal right now for today is to use sine, cosine, and tangent ratios to determine side lengths and angle measures in right triangles. All right? So if you don't have a calculator, have a calculator handy. We're going to be using it a little bit today. But what are trig ratios, and what is this SOHCAHTOA? Well, SOHCAHTOA. Now, chances are you've learned this before and actually spelled TOA wrong. But these are trig ratios to help us to find missing pieces of triangles. So the SO comes from the sine of an angle. So remember, this x is always an angle. O, H, and A are always side lengths. So O would mean O is opposite. H is hypotenuse. And A would be adjacent side. Those are all sides. So if we're looking at the first trig ratio would be sine. S stands for sine of an angle is equal to the opposite over hypotenuse sides. So if we're taking angle x, and again, they can only work for the non-right angle. So trig ratios are for right triangles only. Okay. And it only works for the non-right angles. So we can either deal with this one or this one. This one is labeled x. So if we're taking the sine of x, you type in sine of whatever the angle the x is, it'll end up being equal to the opposite side over the hypotenuse, O over H. Same thing with cosine. So cosine of that angle would be adjacent, so the adjacent side, the one that's next to it, over the hypotenuse. And tangent would actually be the opposite over the adjacent side. So those are where the trig ratios come from, and we can use those to find either missing sides or a little bit more work to find the missing angle. But we're going to do both today, finding missing sides and angle. So we're going to use those. Let's just practice setting up those ratios first. Got a couple problems here. And I'm only going to do some problems from each. So try to do the other ones on your own. But it says write the ratios for sine, cosine, and tangent of angle D. So we're going to do sine of D, cosine of D, and tangent of D. Now remember, SOHCAHTOA. SOHCAHTOA, SOHCAHTOA. So means sine of the angle is the opposite side over the hypotenuse. So the opposite side would be, this is the opposite. This would be the hypotenuse, and this would be the adjacent side. So that would be 8 over 15. The cosine of that angle would be the same as the ratio of the, so it'd be adjacent over hypotenuse, or 15 over 17. And then tangent would be TOA, so it'd be opposite over adjacent, so it'd be 8 over 15. All right? All right, we can do the same thing with number 2. Why don't you try number 2 on your own, and make sure if you have a ratio that you can reduce it. Alrighty, so I used those sine, cosine, and tangent, the SOHCAHTOA, to find the trig ratios of each. For sine, it was 5 over 10, so I reduced it to 1/2. Cosine was the 5 square root of 3 over 10. You can reduce the 5 over 10 to 1 over 2. So it's just 1 square root of 3 over 2. And then tangent, we had the radical in the bottom. And so it's 5 over 5 square roots of 3. Now the 5 over 5 is just 1 over 1. But remember, you cannot have radicals on the bottom. So to do that, you multiply both the top and the bottom by whatever the bottom was. Because when you multiply the square root of 3 times the square root of 3, the square roots cancel out, and it's just 3. So, and then we have the square root of 3 over 3. All right, let's use those to find some missing pieces. So you're going to need a calculator. I have this one just in case. I have my own next to me, but if you want to see on a calculator, this is what a sine, it should be on degrees. If you're using this one, it should be degrees because we're dealing with degree measures. If you're just using your calculator, hopefully it's already set to degrees. But we have our sine, our cosine, and our tangent. And in a little bit, we're going to use the inverse of those as well. So you hit the inverse and then sine -1 raised to the -1, cosine raised to the -1, and same thing with tangent. But we're not going to use that right now. So if I go to we're going to do numbers 3 and 5. How about? All right, number 3, find the value of x. Round to the nearest tenth. So we have an angle. It's 34 degrees. We have the hypotenuse, and we're given also, the adjacent. So hypotenuse and adjacent, so we're going to use cosine, because the would be cosine is adjacent over hypotenuse. So the cosine of 34 is equal to x over 8. So to solve for 8, x, multiply both sides by 8. So x is simply equal to 8 times the cosine of 34. And if you want to leave it like that, that would be exact. Or if you type that into your calculator, you just do cosine of 34 equals that times 8 would be 6.63. So if you would round it, we'd say 6.63. All right, and that would be what x would be equal to. That, if you look at it, that would be about right. Now, number 5, we're given the angle 68, and we're given the opposite, and we're given the adjacent. So that would be opposite and adjacent would be tangent, because tangent is opposite over adjacent, TOA. So tangent of 68 is equal to 6 over x. And these are where you got to really think back to algebra how you'd solve for this. You can't just multiply both sides by 6, because the x is on the bottom. So to get rid of this division, we multiply both sides by x. All right? That cancels out here. Now we're left with x times tangent of 68 equals 6. Now we got to solve for x yet by dividing by the tangent of 68. We just treat that as one term, tangent of 68. So x then is equal to 6 times the tangent of 68. Or if you type that into your calculator, tangent of 68. Alright, tangent of 68. Multiply that by, was it 6? Yep. And I got 14.9 if you round it. So let's look at that. That doesn't quite seem right to me. So let's backtrack here. Oh wow, big mistake. Hopefully you caught it. I wrote this as 6 times tangent of 68. It's supposed to be 6 divided by the tangent of 68. So that's 6 divided by the tangent of 68. Alright, or that would be equal to, I'm just going to do it on my calculator right now. 6 divided by the tangent of 68. I get 2.4. That seems more accurate to me if I look at the picture. So always check to see how you're doing there. One word problem. The ramp, I'm just going to draw it out. You're going to solve it then. The ramp on the back of a moving truck. So if this is your moving truck, wheels there, perfect moving truck. All right, but the ramp is coming down. This right here is 3 feet high. Make it a triangle. It says the angle is 25-degree angle it's rising at. And we're trying to figure out how long the ramp is, so we're missing right here. Oops. Right here. So round to the nearest foot. So we have the opposite, and we have the hypotenuse that we're looking for. So that would be sine of 25 equals the opposite, which is 3 over x. All right, and you're going to have to solve that like we did before. Multiply both sides by x and then divide by the sine of 25. So you'll end up getting x is equal to the 3 over the sine of 25. So if you need to look back at our work from up there, look at our work up there. But then if you take that and put that into your calculator, you do 3 divided by the sine of 25, you end up getting 7.09 or 7.1 feet. And that makes sense to me. That makes sense. 7.1 feet looks about right. All right, let's go on. Some different examples when we have to go backwards. So we're just going to do a couple examples of finding the angle measure because we don't have the angle measure. So that's where you have to use the inverse sine or the inverse cosine or the inverse tangent. So let's look at number 7 and number 9, and then we'll probably call it quits. Find the value of x. So we have x, we have the opposite, and we have the adjacent. So opposite and adjacent makes tangent, so TOA. So tangent of x would be equal to 3 over 10. Okay, so here's the trick. We need to use the inverse, and if you look at, to undo tangent, to get the x by itself, we have to use the, let's see if I can move this over here. We have to use the inverse tangent. So that would be the tangent -1 of this whole thing, and you do that to the left or the right side as well. All right, and you take your calculator, and I'll show you. It's just going the opposite. It's almost like we're doing the opposite operation. So if you use the inverse tangent, and to solve that, it would be 3 divided by 10 in there, which would be 16.7. All right. So that would be, if you're looking at this, actually, these two things cancel each other out. So x is equal to the inverse tangent of 3/10. And I just checked it. I think it was 16.7. So that's one of the harder things to I don't know, to understand for a lot of students, but you really got to use your calculator for these. But it's the opposite. So the inverse operation and the inverse of tangent is inverse tangent. That's what they call it. On the calculator came up with arctangent. You'll understand more about arctangent, how it's almost identical to inverse tangent, but that's just how it showed up on there. You'll do more of that in Algebra 2 and with trigonometry. So let's go to number 9. We have the x. We also have the adjacent and the hypotenuse. So that would be cosine. It would be adjacent over hypotenuse. So cosine of x is equal to 11 over 12. Now you might be able to guess, to get rid of the cosine, we do the inverse cosine of that. And we do that to this side as well. So these cancel each other out, and you have x is equal to the inverse cosine of 11 over 12. And when you check that out, let's see here, the inverse cosine of 11 over 12, 25.6 if you would round it. And that would be degrees again. I didn't put in degrees here. This would be degrees here as well. And that, I would say that does look accurate as well. So you got to know how to use that inverse tangent to solve. Let's just look at one real world problem, see if we can figure this one out. It says Jed is building a roof for his shed. Here's his nice little shed here. The highest point on the roof will be 3 feet higher than the top of the shed. So I guess the top of the shed would be right here. And all the way up to here would be 3 feet. The slanted roof is 7 feet long. So this right here is 7. So if we want to finish this triangle, it'd be like here, here, here. And it wants to figure out the measure of the angle formed by the top, that should say top of the shed, and the slanted roof. Top of the shed and the slanted roof. So looks like we're looking for this angle right here. So to figure out this angle, we have to figure out this angle, because this is the, or we could do it this way. We could do, this is 3. This is our triangle here. 7, and that's 3 feet. We could do it that way. We're trying to find this angle right here. Hopefully you're following with me. But if we're trying to find that angle as x, we'll use a different color. x, 7 for right here, 3 for right here. We have the opposite and we have the hypotenuse. So opposite and hypotenuse makes sine. So the sine of x is equal to the opposite, which is 3, over the hypotenuse, which is 7. And again, to get rid of that, you do the inverse sine. You do the inverse sine to this side. So x is equal to the inverse sine of 3/7, which then would be equal to, well, let's figure out in our calculator, the inverse sine of 3/7 is 25.4. So it'd be 25.4 degree angle. All right. So that is that. I'm just going to leave you with the closing questions, and I'd like you to answer the other questions if you can, from the lesson. So that is it for section 383. I hope you learned something about trig ratios and SOHCAHTOA. We'll see you next time.